This is the pH neutralization system. It is a fully automated system with automatic controls and alarm system. The pH neutralization system controls the pH of wastewater before discharge. So, what is pH? In more practical terms, although not technically correct in all cases, pH is the measure of acidity or alkalinity of water. Measured on a scale of 0 to 14, solutions with a pH of less than 7 are acids, while solutions with a pH of greater than 7 are bases. In very simple terms, bases are used to neutralize acids, while acids are used to neutralize bases, or caustics. The byproducts are normally salts, which may or may not be soluble, and water. The task of any pH adjustment system is to adjust the pH of the process stream into the defined acceptable discharge range. In the case of an acid neutralization, caustic, NaOH, is added to the effluent stream to neutralize the pH of the solution. The most commonly used chemicals for acid or base neutralization are 98% sulfuric acid and 50% sodium hydroxide. In many cases, these are very good choices. However, there are many considerations when selecting chemicals, and these may not always be the best selection. The selection of the chemicals used for the neutralization of an acid or base is almost as important as the design of the neutralization system itself. These considerations range from health and safety to cost and convenience of operation. Some of the major points to consider in the selection of chemicals are health and safety, cost and convenience, and storage environment and location. To neutralize an acid or base, a source of hydroxide ions, OH negative, or hydrogen ions, H positive, are required respectively. An acid must be neutralized with a base, which by definition is characterized by an excess of OH negative ions. Likewise, a base must be neutralized with an acid, which by definition is characterized by an excess of H positive ions. The solution that is transferred from the surge system area is collected within the primary pH neutralization tank. Using the control panel, an operator may begin the mixing process, agitating the water. The pH electrode senses the pH and displays the results on the control panel. The chemical metering pump dispenses caustic from the first chemical drum through the metering pump to the tank to increase the solution's pH from 3.0 pH units to 6.0 pH units. In the event the pH increases to over 9.0 pH units, the acid dispenses to decrease the pH to 7.5. As the water solution mixes together, it eventually cascades from stage 1 pH to stage 2 pH, where the mixer continues to agitate the solution within tank 2. The second caustic metering pump feeds the chemistry once again to increase the pH from the 6.0 pH units to 7.5 pH, and if the pH should increase more than desired to over 9.0 pH units, then the acid pump feeding this tank will feed acid to decrease the pH to 7.5 pH units. The solution continues to agitate as the water cascades over from stage 2 and the treated pH neutralized wastewater is passed under gravity flow conditions to the final pH monitoring device and flow meter. The final pH meter is for monitoring purposes only. No chemicals can be controlled through this meter. The numerical value of the final pH and discharge flow rate are continually and instantaneously recorded on the panel-mounted digital chart recorder. After the pH is monitored, the flow continues through the effluent pipeline, gravity-fed to the sewer.